So now that we know what matrices are, we can use them. You can use augmented matrices to solve systems of equations. And the nice thing about using matrices is if you have a system of two equations with two variables, no big deal. Three equations with three variables, we can definitely work with that too. But if you start getting into more variables and more equations, then matrices are the only way to go because it will take you hours and hours to solve the system otherwise. So you can solve any system of equations using an augmented matrix. What we're going to do is use elementary row operations on the augmented matrix to make it look like this. This is our goal. If this was a system of two equations with two variables, we want to make our matrix turn into something like this. If we had a system of three equations with three variables, which we will eventually, we would want our matrix to wind up looking like this. If you notice, sitting right here would be an identity matrix, and then this is your answer column from the augmented matrix, okay? So this is an augmented matrix right here. You wind up with an identity matrix here, 2 by 2, and then your answer column over here. If you get it into this form, or this form for a system of three equations with three variables, then your answer is sitting right there, the ordered pair A comma B. Or in this case, the ordered triple A comma B comma C. That's the nice thing about matrices. Your answer pops out at you immediately. I say immediately, but I mean it's just sitting right there. It's not really immediate. So the elementary row operations that we're going to be using are listed right here. There's three of them. These are the rules that you can follow to solve a system of equations using matrices. The first rule is you can interchange any two rows. So like if I was working with this type of matrix right here, I could take this row and swap it with this row if I wanted to. This one would become here, this one would become here. That's the first rule. The second rule is I can multiply all the elements in a row by any number I want, as long as it's not 0. Generally, we don't multiply everything by 0. That just makes everything disappear, and then what's the point? So you can multiply any row times any number you want at any point, as long as it's not 0. The third one is sort of a extension of the second one. You can replace any row with the sum of that row and some other row. And you can multiply that other row by any number you want. So I can multiply this row by 5, let's say, and then I could add that to this row and then replace this row with that new answer. Those three operations that we're doing here are the process of row reduction. And all you're going to do is turn your augmented matrix, the original coefficient matrix that has the answers tacked on in the end, you're going to try to turn that matrix into something that looks like that. And as soon as you do, then you have your answer. Okay, so we have a couple systems of equations here. We're going to use matrices to solve. So we're going to have to create an augmented matrix first, and then we'll use row operations to reduce this thing down to an identity matrix and an augmented answer matrix. Okay, here we go. The augmented matrix will be 2, -3, my bar, and then 3, 1, 1, and 14. Okay, so I want my answer to look like this. I want it to be 1, 1, with zeros in between, and then some sort of number here and some sort of number here. That's my goal. So the first thing we're going to do is try to get a 1 in this upper left-hand corner. Once we do that, we'll get the 0 here. Then we'll try to get a 1 here. Once we do that, we'll get the 0 there. So we're starting here and working our way around. Okay? Kind of like a puzzle. So I need a 1 in the upper left-hand corner. I don't have a 1 there right now. But I do have a 1 right here. And one of my rules is that I can interchange the rows if I want to. So I'm going to swap this row for this row. And then I'll have that 1 sitting right there. Okay? Now there's a way that you have to write that. I'm going to draw an arrow over, and it needs to be kind of a longer arrow because I'm going to put some writing in between. I'm going to write row 2 becomes row 1. All that's doing is telling me what it is that I just did from that first step to the next step. Now I can rewrite my matrix. It is now this row on top, 1, 1, 14, and then this row on the bottom, 2, negative 3, 3. The next thing I need to do is turn this position into a 0. So this 2 right here has to turn into a 0. Now the way that I'm going to do that is with that third elementary row operation. I'm going to create opposites in my mind. The opposite of 2 is negative 2. So what I'm going to do is I'm going to take this row right here, and I'm going to make that 1 a negative 2 in my brain. So I'm going to have to multiply this entire row right here by negative 2 in order for that to happen. Do you agree? Okay, but I'm not going to write that down. It's going to happen in my head. So I'm drawing my arrow over, and I'm saying that I have to multiply row 1 times negative 2. So I'm going to write down negative 2 times row 1. Then what I'm going to do is, because I've created opposites in my first row, I'm going to add that to my second row, kind of like when we used elimination and we made opposites and we added them together. It's the exact same thing here, it's just that we're not writing down those equations again. So I'm going to add that to row 2, so I'll write plus row 2. And now once I've done that, I have the option of replacing my row 2 with what I get from that situation. So I'm going to take my answers that I get and replace row 2. So the top of the arrow is the operations that I'm doing. The bottom of the arrow is where I'm putting those answers. Okay? I am not changing row 1 at all. In my mind, I'm working with row 1 and adding it to row 2. And then my answers become my new row 2. So here's what it'll look like. In my mind, I take 2 times row 1 and add it to row 2. So negative 2 times 1 is negative 2. Plus 2 is 0. And I'm replacing row 2 with those answers. So I put a 0 there. Do it again for the second position. Negative 2 times 1 is negative 2. Then I'm going to add that to that, and I get what? Negative 5. It's negative 2 plus negative 3, which is negative 5, and I can write that there. I have to do the same thing for the last column as well. Negative 2 times 14 is negative 28 plus 3, negative 25. So I put negative 25 there. That's my new second row. I didn't do anything to the first row. I changed the second row. So I'm going to rewrite the first row. 1, 1, 14. All right, so at this point we have the 1 in the right position, we have the 0 in the right position. Now we got to get a 1 right here. Well, remember, one of the rules is I can multiply any row I want times any non-zero number. So what could I multiply this bottom row by to turn that negative 5 into a 1? Negative what? Negative 5 times negative 5 is positive 25. Negative, as a fraction, that would be 1/5, the reciprocal. Multiplied by the reciprocal gives you a 1. Okay? So I'm out of room over there. Normally I would just draw another arrow, but I don't have room to do that, so I'm going to draw my arrow here. And I'm going to multiply row 1 times negative 1/5. Sorry, not row 1. Row 2 times negative 1/5. I didn't do anything to the top row then, so I'm just going to rewrite it. 1, 1, 14. My bottom row, negative 1/5 times the number in this position is 0. Negative 1/5 times the number in this position is 1. And then negative 1/5 times negative 25 is positive 5. So we got one more to go. We got to turn this number right here into a 0. I can't multiply by 0 ever. So I'm going to draw an arrow over. And now the goal is to make opposites here. I have a 1 sitting right here. So in my mind, how can I make opposites with these two numbers? Good. Multiply this row by negative 1. So if I write negative 1 times row 2, then I'm going to add that to row 1. And where will I be writing my answers? In row 1. So in your mind, take the first position here, negative 0 would just be 0 still, plus 1 is 1, and I'm writing my answers in row 1, so I put a 1 there. Negative times 1 is negative 1, plus 1 is 0, and I'm writing my answers in row 1, so I put a 0 there. And then finally, negative 1 times 5 is negative 5. Plus 14 would give me 9. And I write my answer there. I did not replace row 2. Row 2 stays exactly as it is. 0, 1, 5. So now this matrix has the look that I want. It has the identity look right here. And then it has the A and the B sitting right here. So what we're going to say is that this column represents our X. This column represents our Y. Because remember when we made this matrix, it was 2X, negative 3Y, 1X, 1Y. This column represents my X's. This column represents my Y's. So this is actually 1X equals 9. And this one is actually 1Y equals 5. So my answer is 9, 5. All right, we need to do the second one. So the first thing we need to do is what? We're going to talk our way through this one. Build a little matrix. So form your augmented matrix, which will be what? Okay. I think I heard the mumbling correctly. There's your augmented matrix. Now, what are we looking for? What are we trying to do here first? Yeah, we want a 1 in this position right here. Well, we don't have that, but we do have a 1 in this position right here. So we can swap the rows. So I'm going to draw an arrow, and how do I write swap the rows? R2 becomes R1. All right? So then row 2 is now row 1. So 1, negative 1, 4, and negative 5, 3, 6. Okay, so that gives us that one right there. Where do we go from there? We want the 0 here. Negative 5 has to turn into a 0. So that means I need to do what? Top row multiplied by 5. So I'm going to draw my arrow over and I'm writing what? 5R1. And we're going to add that to R2 because we're making opposites and opposites add to be 0. And we're going to replace row 2 with our answers. Okay, now at this point, am I changing row 1 at all? No, so I can rewrite that row right now. 1, negative 1, 4. I'm replacing row 2. So I actually do it that way because then I don't forget that that's where I'm putting my answers right there. Okay, now in our heads, we do 5 times the position in row 1 and add it to the same position in row 2. So 5 times 1 is, plus negative 5 is, and I write that answer in row 2, right there. Continue. 5 times negative 1 is and add that to the 3, and we get -2, and we write -2 right there. Finally, 5 times 4 is 20. Add that to 6, and we get 26. 20 plus 6 is not 22. You said 14. Oh, it's adding. We're just adding these. Okay, so now we have this position. What's our next move? No, our next move is to get that guy. We want a 1 right there. So I got to turn -2 into a 1. How do I do that? Going to multiply row 2 by need to multiply row 2 by the reciprocal of what you see, which is going to be -1/2. That's a -2 right there. I got to make it +1. So I got to multiply by -1/2. The reciprocal of -2 is -1/2. Trust me. Did I do anything to row 1? No. So I'm going to rewrite it. 1, -1, 4. -1/2 times 0 is 0. -1/2 times -2 is 1. And then -1/2 times +26 is -13. Okay, that gives us that guy. We're almost there. I got to turn that -1 into a 0. So I need opposites here. Yeah, we already have opposites actually. So I don't have to multiply the bottom row by any number. I'm just going to write row 2 plus row 1. And where am I writing my answers? In row 1. Okay, now, am I changing row 2? No. So I'm just going to rewrite it 0, 1, -13. And now I'm adding row 2 to row 1 and writing my answers in row 1. So 0 plus 1 is 1. 1 plus -1 is 0. And then -13 plus 4 is -9. So my answer is now staring me in the face because I have the identity sitting here. It is x equals -9, y equals -13. So therefore my ordered pair is -9, comma, -13. There's your answer. All right, we have one more matrix that we can do. Augmented matrix. What is it? Okay. What should we do first? We have this one already. Okay. So draw my arrow over, and what do I need to do? So multiply row 1 by -2, so -2 R1. What are we doing with it? Adding it to row 2, and we're replacing row 2 with our answers. So, can I rewrite row 1? Okay. 1, 2, 6. Now in our head we do this math. -2 times this position would give me -2 plus 2, which is 0. And then my next position will be, which is -4 plus 1 is -3. And then -2 times 6 is +9. All right, so kind of a bummer. Notice that we had 1 and 1 in the right spot. But when we did this first one to get the 0 there, we wound up with not a 1 there. So no, actually that is okay. Just because we have a 1 and a 1 here doesn't mean that we're good to go and we're not going to have to work with it, okay? The process is still the same. We need a 1 there, and then a 0 there, and then a 1 there, and then a 0 there. You have to follow that routine around. Otherwise, you'll screw up. So now I need to turn that into a 1. How can I do that? Good. Negative 1/3 times row 2. I'm not doing anything to row 1, so I just rewrite it. And then my new row 2 becomes what?
0, 1, 1.
It's a negative 1/3 times negative 3, so it's also positive 1. We're almost there. What do I need to do now? So negative 2 row 2. What am I doing with it? Plus row 1. What am I doing with that? It's becoming my new row 1. So matrix, what row can I put down right now? Rewrite row 2. And then first position in row 1 will be 1. Second position will be 0. Third position will be 4. So we get x equals y equals 1. So my ordered pair is 4, 1. Notice that now that we're doing this a few times, it's taking less time. So the nice thing about matrices, obviously we've been working with just a system of 2 equations with 2 variables. The nice thing about matrices is you can solve them with any number of variables and any number of equations. So this little view right here is showing me just some unknown number of rows. I have 1, 2, 3, 4, I don't know how many rows that is. I have a bunch of columns as well, but the result is always the same. You wind up with an identity here, all 1s along the main diagonal, all 0s everywhere else, and then your answers are sitting right there as an ordered triple or an ordered quadruple or whatever it is. Okay? The process is also the same. You get a 1 right here, and then you get 0s in this entire column. Then you get a 1 right here, and then you get a 0 there, and everywhere else in that entire column. And then you just work your way across. A 1 here, 0s here, 0s here. And then you just keep going. And eventually you will get all just 1s along the diagonal and 0s everywhere else. So what we're going to do now is move into a 3 by 3. So a matrix of 3 equations with 3 variables. And we'll try to do that. Your eyes hurt? You should be feeling really good right now. Here, let me introduce some more soothing lighting. There we go. Your eyes feel better now? Are you crying? There's crying towels over there. I need to start by doing what? So my augmented matrix will be 2, 3, negative 1, 1. And then 2, and then 8. Okay, and then? Good, 0, 2, 3. So it's very important when you're doing this that all your variables match up. Notice I have all my A's there, I have all my B's there, I have all my C's there, and then all my answers are on the other side of the equal sign. It has to be that way before you set up your augmented matrix. Okay? So if it's not given to you that way, you need to put it that way, and then include 0s when you have a missing variable. So we added a 0 in right there. Every position has to be accounted for. So the first thing we would want to do here is what? We need a 1 in the upper left-hand corner, and we don't have it. So what you could do at this point is figure out which equation is going to be the easiest to get a 1 there. I could multiply this by 1/2, but then I'll have a fraction there and there and there. I could multiply this one by negative 1/4, but then I'll have a fraction there and there and there. Not there. I could multiply this one by negative 1/2. I'll have 0 there. I'll have 1 there, but then I'll have a fraction there. So if it was me doing this by hand, I would put this row up top and then multiply that top row by negative 1/2 to make that 1. Or use your calculator. So let's get our calculators out and open up to the calculator part of the calculator. So from the home screen, I'm just going to the calculator. There it is. And what I'm going to do is pick there's a button on here. Let me show you where that button is. It is just below the delete, right next to the 9, right there. This one that has a bunch of squares on it. That's a template button. There's a whole lot of templates on these calculators. And when I press that template button, I get all kinds of things. I have, let me just point out a few here. This is a template for a fraction. This is a template for an exponent, square root, nth root, which we'll get to, e, which you'll learn next year, log, which you'll learn next year. This is a piecewise function. This is a multiple piecewise function. So there's lots of stuff on here that you already know. This one right here that's highlighted right now is absolute value. This we'll get to this year, but we might not use it. There's a matrix. It's a 2 by 2 matrix. There's another matrix. It's a 1 row by 2 column matrix. There's a 2 row by 1 column matrix. We'll use these towards the end of the year. And then finally this one is a 3 by 3. It looks like a 3 by 3, but actually it is the one that allows you to define the dimensions yourself. So I'm going to click on that one, and then it brings up a window, and it asks me, well, how many rows do you have? So for this problem, how many rows do we have? 3. For this problem, how many columns do we have? 4, because it's an augmented matrix. So we're going to click 4, and then hit enter, and it gives us our template with all of the rows and all of the columns, all the positions that we need to fill in. So now we can fill all these positions in. So I'll go ahead and do that. We have 2, and you can arrow over 3 and -1, and then the answer is 1, and so on. So once I have that matrix entered in, I'm just going to hit enter. Now, I would always check to make sure that I've entered all of these little coefficients in correctly. Once I've done that, the calculator will do this math for us. All we have to do is make sure it's entered in correctly, and then enter in the correct command to make the calculator do what we want it to do. In the note packet, I told you that this process that we've been doing was called row reducing. So the answer that we've been finding was called row reduced echelon form, RREF. That abbreviation is the command to do this math. So we're going to type in RREF parentheses. So you'll see that. Now what you're going to do is go up and select that matrix, just highlight it so that it's blue, and then hit enter. It will automatically put that matrix in there for you. And then press enter, and it gives you the answer matrix. So the answer is x equals 1/2, y equals 2/3, z equals 2, or whatever the variables were that we were using. So 1/2, 2/3, 2. That's the answer. I need to see the answer matrix though. So you'll write 1, 1, 1, 0, 0, 0, 0, 0, 0, and then 1/2, 2/3, 2. There's your answer matrix. You now don't have to do anything else. In between, I want you to write RREF to remind you of what that code is that you have to enter into the calculator. This is what I expect to see on these problems. You do not have to do the full, long process that we've been learning. You can just use the calculator, but I have to see the coefficient matrix, I have to see the arrow with RREF, and I have to see the answer matrix. And then you can give me your ordered triple of 1/2, comma, 2/3, comma, 2. Go ahead and do the same process for the second one. Make sure you are entering zeros in the correct positions, and then RREF, and get your answer. So we need to write down the coefficient matrix, which is what? Yeah? 0, negative 8. Okay, so we have to show that on our paper. Then we have to draw the arrow over and write what? RREF. That helps to remind us that that's the code that we need to type into the calculator. And when we do that, we have to write down the answer matrix, which looks like this. 1, 0, 0, 0, 1, 0, 0, 0, 1, the bar, and then the answers are 1, 1 half, 3. Close the matrix. And now I can write the ordered triple, which is going to be 1, comma, 1 half, comma, 3. There's my answer. So I want to show you guys one more thing before I let you loose on this section. I'm going to go back to that last matrix that we just solved and got 4, comma, 1. I want to do this to this one. So let me bring up my calculator. Here it is. I have REF already typed in, but I did not type in the matrix yet. So inside the parentheses now I can add that matrix. So I go to my template and I bring up that 3 by 3 and I tell it that I need how many rows? There's 2 rows. And I need 3 columns. So I'm good to go. Enter in the coefficients, which are 1, 2, 6, and then 2, 1, 9. Is that the correct matrix? So I press enter, and it gives me my answer matrix. You can use matrices to solve any system of equations, no matter what the dimensions are, even a 2 by 2. Now how many of you like matrices?
Yeah.
Definitely way better. So let me say, once again, one more time, that if it specifically tells you to use a particular method, you have to use that particular method. But at least you can check it using a matrix to make sure you have the right answer. So you can know the answer before you even go into it. But if you just give me an answer, or if it specifically says solve using substitution, and you solve it using a matrix, and you don't give me substitution, I won't give you credit for having even the right answer. I have to see what it asks you to give, okay? But if it doesn't say specifically anything, you can use whatever method you want. You can use matrices then, okay? And if you're going to use matrices, I have to see the coefficient matrix, I have to see this, and then I have to see the answer matrix, and then give me your ordered triple. That'll be my signal that you did this on your calculator, and then that way I know what it was that you did and whether or not you got the right answer from that.